Nitya. We are going to see the unit 5, that is differential calculus. Today we are going to see the Jacobians in differential calculus unit and their properties as well as the problems also we are going to see. So first let us see the Jacobians definition. If u and v are functions of two independent variables x and y, then the Jacobian of u and v or respect to x and y is defined as j of u comma v divided by x comma y. This can be written as dou of u comma v divided by dou of x comma y. This is in the format of determinant of dou u by dou x, dou u by dou y, dou v by dou x, dou v by dou y. So we are taking the two functions u and v with respect to x and y. So it is an independent variables, depends upon the x and y variables. So it is called as a Jacobian. It can be denoted as in the determinant dou u by dou x, dou u by dou y, dou v by dou x, dou v by dou y. Okay. Next, if it is a three variables u, v, w, that is respect to x, y, z. So it can be written as dou u by dou x, dou u by dou y, dou u by dou z, dou v by dou x, dou v by dou y, dou v by dou z, dou w by dou x, dou w by dou y, dou w by dou z. So these are all the multiple integrals we are going to see with the coordinates. So the Jacobian's definition, is just please write it in the notebook. And properties of Jacobians, that is chain rule we are going to see. First rule is a chain rule. If u and v are the functions of x and y, so for x and y are the functions of r and s. So uv is dependable on the x and y, and x and y is depending upon the r and s. So it can be written as, so it is a continuous chain rule. It's looking like a chain. So u and v, that function is depending on x and y, and then x and y is depending on r and s. So it is a chain process. So for that we have the formula dou u comma v divided by dou r comma s equal to dou u comma v equal to dou x comma y, which into dou x comma y divided by dou r comma s. Next, the chain rule can be extended to three variables also. That can be denoted as dou of u v w by dou of r s t can be written as dou of u v w by dou of x y z into dou of x y z divided by dou of r s t. Second rule is a reciprocal rule. Reciprocal, you know that upside down we have lower classes we had seen that. So today we are going to see the reciprocal rule also. That is dou of u comma v divided by dou of x comma y into dou of x comma y divided by dou of u comma v, which is equal to 1. This is a reciprocal rule, and it can be written as dou of u comma v by dou of x comma y can be written as equal to 1 divided by that term. That is a reciprocal, obvious, we know that. This property can also be extended for the three variables like this way. Next, we can move on to the problems based on the properties and the definition of Jacobian. Find the Jacobian dou of r comma theta divided by dou of x comma y if x is equal to r cos theta and y equal to r sin theta. So here given we have to find the Jacobian. First we are going to use a reciprocal rule. So we know that reciprocal rule is 1 by that term, right? Usually if x means 1 by x is a reciprocal. Likewise the given form is dou of r comma theta divided by dou of x comma y. So reciprocal rule is 1 by divided by that term. So 1 divided by the dou of x comma y divided by dou of r comma theta. See here. Here in the reciprocal term, dou of u comma v can be written as down, and dou of x comma y can be written as in the numerator. So likewise only we should write here. So given condition they have given that x is equal to r cos theta, y equal to r sin theta. So we know that dou of x comma y divided by dou of r comma theta, it is in the definition of Jacobians, that is dou x by dou r, dou x by dou theta, dou y by dou r, dou y by dou theta in the determinant. So they have given x is equal to r cos theta, so y equal to r sin theta. So we are going to differentiate x with respect to r and theta. Likewise we are going to differentiate y with respect to r and theta. So if you are doing, so dou x by dou r equal to cos theta will come. Dou x by dou theta with respect to theta, so minus r sin theta will come. So dou y by dou r with respect to r, that is sin theta, and y with respect to theta, that is r cos theta. Now we can apply here dou x by dou r, that is cos theta, then minus r sin theta. Just apply the four values in the determinant, and determinant you know how to do that. So cross multiplying and the minus, right? So cos squared theta r cos squared theta, then minus and minus becomes just plus, so r sine squared theta. So cos squared theta plus sine squared theta value is 1. So you can take in the r as outside, so we'll get the r as the answer. So this is dou xy by dou r theta is equal to 1 by r. But we need the answer is reciprocal format, that is this one only, dou of r comma theta divided by dou of x comma y. So dou of r comma theta divided by dou of x comma y can be written as 1 by r. We have got the answer as r here, but we are changing the variable, so that is a reciprocal rule we are using. So 1 by r we are getting the answer. Next question, if u and v are the two functions they have given, and x and y also they have given, and find the Jacobian of u comma v divided by r comma theta. So it is, we have to use a chain rule, because they have given uv function as well as xy function also. So uv by r comma theta. So j of u comma v by x comma y into j of x comma y by r comma theta. We are using the chain rule here. So determinant of this one and determinant of this one. So find out the value for dou u by dou x and dou u by dou y they have given. So find out everything first, and then substitute all the values here. After that you can first just determinant you can find, this determinant you can find, then multiply and get the answers. X squared plus y squared is r. We know that the polar coordinates, so x squared plus y squared equal to r squared, so you have to use it and find the answer. Next question, find the Jacobian dou of three variables, dou of x comma y comma z by dou of r comma theta comma phi. Also they have given r x value, y value, z value. I have selected only the important questions only I have selected. So based on this only they will be asking in the university questions, or directly they may be asking this same question also. So now dou of x comma y comma z by dou of r comma theta comma phi, can use the three variables determinant, you can write it. I have already given in the definition. So x of x equal to r sin theta sin phi. So find out dou x by dou r, dou x by dou theta, dou x by dou phi. Likewise for y and z you have to find the differentiation, and you can apply and multiply that. We know that the matrix format determinant, so this one first value into multiplication of this, cross multiplication of this one, and subtraction. Likewise the center value we should remove it, and take the sin theta sin phi into 0 minus cos theta into r sin phi. This determinant you know how to find it, we have done in the matrices also. So from this we can find out, and sin squared theta plus cos squared theta equal to 1. Likewise sin squared phi plus cos squared phi also 1. Okay, so use it, and cos squared phi plus sin squared phi, here also 1 we are having. So apply that and then get the answer as r squared sin theta. So it's an important section, Jacobian, and it is very easiest section also in this unit. Definitely one question, at least in either in 2 marks or 5 marks, they will be asking the questions in Jacobians. Definitely it will come. So don't skip this section. Please learn it. If you have any doubt, you can approach me. Thank you. Thanks for watching.